יפה, כמה זמן ייקח להגיע לשאלה נגיד, קצת לנסוע באמת, אנחנו עכשיו לא עושים לקחת רדיו, נגיד ב-50 דקות. 50 דקות? לא השעה הזו זה... לא כל כך, זה עדיין השעה הזו, אבל נגיד. לא, לא בשעה.
טוב, רוני.
50 ומשהו. לא יודע, סתם, זה עכשיו? תגיד, לא, אתה מביא לי זמן, אתה לא עובד עכשיו. לא אמרת עכשיו. לא אומר לך מתי יוצא. כן, בדיוק. סוף סוף, מה? לא אכפת לי. הכל מרכז בעיר.
I'll speak in English because I can only speak in English. So, okay. So my name is Ronnie. I come from a background of digital marketing, and I got interested in analytics and analytics engineering, and that's what brought me to data engineering. So my project is regarding, I created a web application which does real-time tracking. So the input is provided by the users about the geolocation and the category of the satellites which they want to track over them. So in my case, I took geolocation, like you can provide your own geolocation, but I fixed the category of satellites to military objects. So what my project does, the web application that does real-time tracking and data processing for military objects placed within a given radius. So given radius is also what you provide, and about your location. So that's the idea. Okay, my objective of this presentation or this project was, one, to use open source technologies, to implement a lot of things by my own. So that was very important, like data ops, and focus on how I do it. Especially I wanted to do it in a Linux environment, like cloud-based environment. So that was my focus. So this is the input which the user provides. I don't have a web application like in terms of Flask right now, but I can create it. But this is the inputs which I take. And there are three sources of data enrichment. So first of all, I use this information to query the information about satellites in a given radius of a given category, and it gives me a reply. It gives me a response. Okay, I use this response and I take the satellite ID, and I have another data enrichment source in which I create a table in which it provides more information about the satellite. Okay, so this is another source. So what it does, it provides a repeated object. There's no, I cannot know beforehand how many objects it's going to return. So it's going to return me n number of objects. So what it does is it iterates over the entire response, and does for each response, it looks at the details about the satellite and adds to the object, JSON object. And here I do reverse coding. So if you are giving latitude and longitude, your geolocation, I said, okay, let's use this information and tell me more about the location of the person. Like if I'm giving it, tell me more about the location of that person. The objective is to have a nested JSON. So it's more of learning kind of a project. I get a nested, complicated JSON. That was the objective. Okay, this is my pipeline. And again, like as I said, I wanted to use open source technologies. So this is my application. I have okay. So this is the Kafka topic which I have, app data source. It takes, when I query, it's a real-time processing. So it continuously get inputs data into Kafka topic, and that data is processed here. Then I also configured logging, which is not simple. And that logging I configured so that I could use Elasticsearch and Kibana. That's the objective. So for configuring logging, I use a special class in Python, which was not simple to implement, which converts the log and sends it to the Kafka topic, or app logging. Now I also have two consumers. for one is for the main application data pipeline, and other is for backup because I want to back up the raw data. So that's one of the case of backing up data. And then it's simple. It's not simple, but I then store it in Google Cloud Storage, and then I can use Google Cloud Storage as an external table to first analyze the raw data if I want. And I can also, there's also a need to send a notification. So, okay, let me send an email. So that was the general case. Okay, now my project did not require PySpark, but I wanted to do structured streaming. Why did it not require PySpark? Because my data is mutable, and PySpark generally handles immutable data. But it's okay. I wanted to.
Just to understand, you say hello to the satellite, and the satellite tell you about your environment.
I give geolocations, my geolocations, a search radius, a category of satellites, and it will tell me how many satellites are watching me. That's the whole thing. Yeah. So, and then further on, I wanted to do two things. I wanted to analyze the process data. And another thing was I wanted to implement data prop. Again, it's a different thing. I'll tell you why, and it's not simple. So the entire project I based on my own VM. It has its own IP address. And when I create a data proc, it has its own IP address. It is not simple. I have to configure Kafka to talk to two different IP addresses, which is not simple. Okay, so that's what I did. And one of my cases was, structured streaming. So what I did was I took the entire response, I changed the keys, I made it into a form which can be written to a process topic, application process topic. So that was the thing. And then again, why I'm coming here, I'll tell you. My objective was to use Apache Superset. So it's an open source technology. I wanted to use Docker. I wanted to host it on Docker, and I wanted to configure BigQuery. So which is not simple, but yeah, I did it because I wanted to. The other thing I did, because it's a web application, I wanted to store the process data in Redis, because Redis is the fastest database available right now. So it will process the data as soon as possible, and then in future iterations, I can send a reply back to the Flask, like the front end. So again, Redis was implemented again using Docker. In terms of the performance monitoring, which is logging, again, like Elasticsearch and Kibana was installed on Docker. And how do I store data? So for example, any log which is created, like if you understand logging, it's based on file. So it looks at the file, what file it is reading, and it will automatically create the index based on file. So that was also something which is interesting to do. So I'm not going to explain this because so this is the code which I wrote. I think so it's more of a like implementation details. I'll tell you where it is important, like which part I found it difficult. So one of the part was making my VM, like my compute engine, talk to Kafka, like the data proc cluster.
You can show us how many satellites we have here in.
I can, but I need to run my project. I also have a video that my project is working. What happened is
I really want to know how many satellites we have.
Right now, what I need to start running it. And the other thing is, because of that log4j, Google actually suspend my data proc cluster. I'll show you. So
you are not alone like this, Ronnie. Log4j stuff.
Classify what kind of satellites. Because you know there's a satellites for energy, for weather.
So yeah, there are 30 categories. There are few categories of satellite. I wanted just to use this. I wanted proof of concept. My focus is on just using the technology, setting it up, data ops, that kind of stuff. So I'm not solving any problem. No. So this is the Kafka topic I created. Okay, the other thing is what I've done is I've divided my project into microservices. So for each segment of the project or each data pipeline, there is a GitHub repository. So if I want to fix something, I'll just work on a part of a code and not everything. So that's something just interesting. So, okay, this was interesting because this information more about the satellite is not in a structured format. It's not very difficult to create an ERD, like, so because it's one-to-one relationship, so it's not difficult. So that's what I did. And the interesting part is this one. Okay, so what this does is converts the I query the data. It's a join table, and then I make it send a it as a JSON object, which is very helpful.
You collect all the attributes and
yeah,
send it to
yeah. So I join all these tables. This is the fact table. Like you can say it's not like it's an ERD, so it's not a fact table. But I join all these things, and then I send it as a JSON object, because then I have JSON. I can connect to JSON, and what it does is it looks at the satellite ID. Yeah, so that's what it does. Yeah. And this is the data prop. Okay. The idea actually was to insert the data, but it's again, I told you, like it's mutable, and Kafka PySpark is not for mutable data. But the idea was to have the data appended using PySpark, but that is not the case. That it didn't work for me. So what this does is it listens to the app data, it takes the input, it changes the form so that we can write it to a Kafka topic, and then it writes it to a different app data processed Kafka topic. That's what it does. And again, you see, this is different. And the compute engine IP address is different. So this was very tricky to set up, especially because I didn't know, like it was something new for me. So I had to figure it out. Stack Overflow. Yeah. So yeah, that's my Dataproc cluster. This is a Redis. Yeah, this is okay. The backing, like I back up the process data.
Can show what the front end? Something.
There's no front end.
Video.
Oh, yeah, there is a video, of course, but it's like 10 minutes long. 10 minutes long. Oh, okay. Of course, there is a video. So, okay, the other thing was, yeah, Google. I wanted to use Apache superset, so I visualized it in Apache superset. Like, and the other thing was it's a nested JSON, and like this is a visualization. Again, I hosted. You can look at the IP address. So that's my compute engine. It's not localhost. It's not easy to do that, but yeah, it's fun. And this is the Apache. No, this is Elasticsearch Kibana. Logging. This is again something which is complicated. And yeah, an Elasticsearch. There is a proof. And yeah, finally this thing, right? I send an email. So how do I send an email is also a little complicated.
The email is how much satellites
no.
we have around it.
No, this is for the backup. So there are data. I backed up the data. So when I send an email, I use Jinja templating to create an HTML email. So that was also something new. It took time to figure out, and it is, yeah, it has some kind of complexity also. So yeah, and of course, it was like real-time application. So I also try to do it on Airflow. I installed a local executor on Airflow using Postgres. I didn't use MySQL because I wanted to do it my own. And yeah, this worked. The only thing is I'm using a real-time application, and there is not a lot of things where I can use Apache Airflow for. So what I did was, this is also interesting. This took time to figure out. Yeah. So okay. So I need to start Zookeeper and Kafka server, but that would not run the tag. It will just keep it running. So what I need to do is I need to run Zookeeper, I need to run Kafka, and then I need to make the process return an exit code 0, which is successful. Only then it will go forward. So this is what it does. Like it looks at Zookeeper Kafka, and then it gives the exit code. So the success, the DAG shows a success, and then it can process the data further. Like, yeah, everything on GitHub. Branding. Okay, so video. It's a long one, but can I increase the speed of the video? Playback, yeah. Why not? So like I created everything. This Kafka Zookeeper, it's okay, right? So I showed that it is running. I just wanted to back up because I thought that something can go wrong. So let me save it. And it did go wrong because I was not ready for log4j. And like, okay, this is logging the data to Elasticsearch. Like it. This is the backup, like backing up process data. Mail send. This is the data prop.
Yeah.
So I'm using Jan, so it's like it's on the cluster. That's for sure. Okay. This is backup. This is Apache superset. So I run an Apache superset. Backs up source. So it comes as a nested JSON object one, just so that I can use BigQuery and say that okay, there is a nested object. I can use a dot notation. So this is Apache superset. And great states. And this is finally ready. So it runs. Thanks.